So in the previous question we have seen all the binary numbers which should be divisible by 2. Now we shall extend this question. Again we are looking at binary numbers, but here the number should be divisible by 3. So the question is, construct a minimal DFA which accepts set of all strings over 0, 1 which when interpreted as binary number is divisible by 3. So instead of 2, now we have to divide the number with 3. Again, whenever I divide any number with 3, what are the possible remainders? We are talking about binary numbers. So input alphabet is 0, 1. Now whenever I divide any number with 3, what are the possible remainders? One is I can get a remainder of 0, or I can get a remainder of 1, or I can get a remainder of 2. Q0 represents set of all strings which generate a remainder of 0, set of all strings which generate a remainder of 1, set of all strings which generate a remainder of 2. So all the strings present in 0, 1 star according to this problem can be classified into 3 classes. One is the strings which generate remainder 0. For example, 0, 1, 1, 1, 1, 0, so on. This is nothing but 0, this is 3, this is 6. And the all strings which generate remainder 1, which is nothing but 1 and then 4, so on. Now set of all strings which generate a remainder of 2. So what are the strings which generate a remainder of 2? 1, 0, 1, 1, 0, which is 6, it is 2, it is 6, so on, right? So I can classify, I can take any string from this language and I can place it somewhere. Finally we have to accept set of all strings which are divisible by 3, which means which generate a remainder of 0 when I divide it with 3. So first step is, after identifying number of states, we shall fill up the transition. Let us say I am in Q0, and if I see 0, what happens? This is the first string I am going to see. When I see 0, when I divide it with 3, the remainder is going to be 0 only. Therefore, any number of zeros, I will be in the same state. Okay. Now, if I see 1, what happens? If I am in state Q0, which means starting, if I see 1, the string is going to be 1 itself, the value is 1. If I divide 1 by 3, then the remainder is going to be 1. Okay. Now let us say I am in state Q1. First thing you have to decide is, how did I reach this state Q1? I have reached state Q1 upon seeing 1. So the history of the string is 1. We have already seen 1 and we are in Q1. And if I see a 0 in Q1, the total string is going to be 1, 0, and the binary value, if it is a binary string, the decimal value is going to be 2. So we got 2. If I divide 2 with 3, the remainder is going to be 2. Therefore, I am going to Q2. And Q1 on 1, which means I am in state Q1. How do I reach Q1? By seeing 1. And if I see a 1, after 1, the entire string is going to be 3 in decimal. So if I divide 3 by 3, then it is going to generate a remainder of 0. Therefore, on seeing a 1, I am going to come to Q1. Fine. Now let us talk about Q2. If I am in state Q2, how do I reach Q2? By seeing 1, 0. So 1, 0 base 2, if it is a binary number, in decimal it is going to be 2. Okay. So if I am in state Q2, by looking at 1, 0, if I see a 0, the entire number is going to be 4. 1, 0, 0 is going to be 4. Now what is 1, 0, 0 remainder when divided by 3? What is 4's remainder when divided by 3? It is nothing but 1. Therefore, on seeing a 0, I will come back to 1. Now if I am in 1, 0, if I am in state Q2, which means I have seen 1, 0, I have seen 1, 0 and I am in Q2. If I see 1 next, then the total number is going to be 5. Now if I divide 5 by 3, the answer has to be 2. Therefore, any number of 1s, the remainder is going to be simply 2. So this is the diagram of how you can represent the problem. Now let us draw the transition table for this diagram. This is called transition diagram. There are two ways in which you can represent a finite automata. One is state transition diagram, other is state transition table. So let's see how does the table look like. Rows is nothing but number of states. The number of states here are Q0, Q1 and Q2, and columns is nothing but number of inputs 0, 1, and just fill all the transitions. Q0 on 0 is going to Q0 and Q0 on 1 is going to Q1. Q1 on 0 is going to Q2 and Q1 on 1 is going to Q1 on 1 is going to Q0, and Q2 on 0. Q2 on 0 is going to Q1 and Q2 on 1 is going to Q2 itself. So what is the final state? It has to be divisible by 3, therefore final state is going to be this one. This is the initial state. Initial state is represented by an arrow and final state is represented by a star. This is the table and this is the diagram. So one interesting point is the question can even be extended like this. The number need not be divisible by 3. They can ask the number, the binary number should be congruent to 1 mod 3, which means if I divide the binary number by 3, remainder should be 1. In that case, the final state will be Q1, not Q0. Or the question can be congruent to 2 mod 3. In that case, the answer, the final state is Q2. So the final states will change. There are some points worth noting here. If the question is divisible by n, if the question is about divisible by n, then number of states in the DFA is going to be n itself. If the question is all about divisible by n, then the number of states is going to be n itself. If the question is about divisible by okay, we shall extend it later. Now just look at this diagram. I have copied this from this. You understood how to do this. From this I am constructing this, but with experience, after solving a lot of problems of this model, I found out a shortcut, a simple shortcut, and the shortcut looks like this. So in order to construct the diagram for any such question, you directly write the number of states. You know the number of states. How? If it is divisible by n, then it contains n states. Since it is divisible by 3, the question is about divisible by 3, the number of states is Q0, Q1, Q2. Once you find out the number of states and once you have written the columns, just follow this sequence: Q0, Q1, Q2, Q0, Q1, Q2. I'll explain this better with one more example.